As a continuation of our studies in the relationship between diet and disease, I'm happy to have here with me Dr. Robert Lustig. Dr. Lustig is a pediatric endocrinologist at the UCSF Benioff Children's Hospital. In addition, he is also a member of the Institute for Health Policy Studies here at UCSF. Thank you for joining us today.
My pleasure, Katie.
So to start out with, some would argue that obesity and overweight is the result of personal behavior. Do you agree or not?
Obviously, personal behavior is what everyone on the planet thinks is going on in terms of obesity. The problem is, how do you explain obesity in 6-month-olds? They don't diet and exercise. The fact is, when you look at the data from the CDC or even from the WHO in terms of how obesity is progressing around the world, it's now occurring in countries that still have malnutrition. This looks much more like an exposure than it actually does change in behavior. The research that we have done has demonstrated very clearly that there is no such thing as behavior. There's really just biochemistry. Sometimes we're smart enough to understand that biochemistry and how it impacts that behavior, and sometimes we're not. But, for instance, schizophrenia was a behavioral disorder for 100 years. We now know it's a defect in dopamine neurotransmission. The bottom line is, that's how behavior works, is biochemicals change in the brain. So the question is, how does that work in obesity? What is driving that behavior? And I can sum that up really in one word: insulin. Insulin does two things. The first thing it does is it drives energy into fat cells, thereby increasing the amount of energy stored, therefore the obesity. But the other thing that insulin does is it blocks the signal in the brain that would normally convey satiety and signaling energy adequacy. That signal is called leptin. And leptin is a hormone that's made from your fat cells, goes to your brain, and tells you you've had enough. But insulin blocks that signal. So by doing peripheral changes which drive energy deposition, and by inducing central changes that drive starvation at the level of the brain, you can see how that would turn into a vicious cycle of consumption and also disease. So what we have learned is that insulin is the bad guy in the story.
So what can families and individuals do to change their biochemistry, or is this something they shouldn't be worried about at all?
Right. So the question is, what caused the insulin rise? If you look at studies from the 1970s in terms of how high your insulin went in response to, say, a glucose challenge, maybe 50 microunits per mil. Now we're up to 100, 150, sometimes even 200 microunits per mil in kids. So the question is, how come these kids are releasing twice or 3 times the insulin that they were before? And that is the crux of the obesity question. So what's changed during that time? Certainly our genes have not changed, but our diet has clearly changed. And what makes insulin go up? Well, sugar. But what kind of sugar? Well, there are 3 molecules that constitute the standard sugars. There's glucose, which is absolutely essential for life. It's so important that if you don't get any, your body makes it in order to keep your blood glucose level up. There's galactose, which is in milk sugar, which is converted immediately to glucose in the liver unless you have a genetic disease called galactosemia, which is very rare and usually kills you by the time you're 2 months old. So that one's not really concerning. And then there's the last one, fructose. Fructose is the sweet part of table sugar. It's in sucrose, it's in high fructose corn syrup, it's in maple syrup, it's in agave nectar, it's in virtually every caloric sweetener. And it's the thing we seek, it's the thing we like. The problem is that fructose is not glucose. Never was, never will be. Glucose is a 6-membered ring. Fructose is a 5-membered ring. Glucose is regulated by insulin. Fructose is not regulated by insulin. Glucose goes to glycogen or liver starch in the liver for storage, and that is a non-toxic storage form of energy in the liver, which is good, and it's what you want to make so that you have ready energy to release when you exercise. So if you're glycogen depleted from either starvation or from severe exercise, you can rebuild glycogen with fructose. But what happens if you're not? What if you're at rest? What if you're energy replete, which is virtually the rest of the world, aside from the elite athlete, and you take in a large sugar load, say a soft drink or a sports drink or one of these energy drinks, which has an enormous bolus of sugar? What happens is that fructose is not converted to glycogen, because the glycogen is already there. It has no choice but to go down to the liver mitochondria, which are the little energy-burning factories within cells. They are overwhelmed, those mitochondria, and they have no choice but to take the extra energy that's been provided by the fructose and turn it into liver fat. Liver fat drives all of the other chronic metabolic diseases. By inducing insulin resistance in the liver, that liver fat drives cardiovascular disease, lipid problems in the blood, dyslipidemia, hypertension, diabetes, and possibly cancer and dementia as well. So that's where the problem is the overload of fructose to liver mitochondria, driving insulin resistance and chronic metabolic disease.
In addition to the highly sweetened beverages, in what other ways has our food supply and beverage supply changed over the past few years towards a shift to more fructose? Is it just sweetened beverages that's the problem?
Well, sweetened beverages constitute 1/3 of our total sugar consumption. Desserts, candy, etc., things that are very specifically marketed to be sweet constitute 1/6 of our total sugar consumption. That leaves 1/2 that is unaccounted for, and that is put into virtually every one of our processed foods. You cannot find a processed food that doesn't have sugar or high fructose corn syrup added to it in some fashion. And it's added for all sorts of reasons. It's added to brown the bread better. Indeed, that browning reaction is called the Maillard reaction. It's the same reaction that causes hemoglobin A1C to build up from glucose, but fructose does it 7 times faster, and that is part of the aging process. It's put in to increase shelf life because it takes the place of water, so bacteria doesn't grow, which you'd say is great for the economy, and it's one of the reasons why food is cheap. The problem is that that bolus of fructose is so large that our mitochondria are overwhelmed. Bottom line, it's your wallet or your health.
Speaking more to the fructose thing, as a dietitian, you teach people that not all sugars are bad, nor are they created equal. And fructose, being a naturally occurring fruit sugar, comes in fruits that have a lot of other benefits as far as fiber, vitamins, minerals, water. Are you saying that all fructose-containing foods are they all created equal, or is there a problem with eating regular fruits in your diet?
So, clearly, I'm not disparaging fruit. If you look at the fructose content of virtually every fruit, there's a straight linear correlation between that fructose and the amount of fiber within the diet, within that fruit. And that's on purpose, because fiber is the antidote. Fiber reduces how much fruit you can eat. We do a little experiment over in the East Bay with a cooking class. My colleague Cindy Gershon, who is a chef, runs this class. Take 2 students. One, you give 6 oranges and you say, here, make orange juice. The kid makes orange juice out of the 6 oranges, 8 ounces, downs it and says, okay, what's for breakfast? The other kid says, we say, eat the 6 oranges. By the time the kid gets to the 5th orange, the kid throws up. Says, I couldn't possibly eat another bite. What happened there? The fiber was the difference. Fiber is an essential nutrient, and fiber has been excluded from our diet because that's what processed food is fiberless food, because you can't freeze fiber. Fiber decreases shelf life, and so it also increases depreciation of food sitting on the shelf. So squeeze it, freeze it, it lasts forever. So the adage I espouse is, eat the fruit, don't drink the juice. The fruit's fine.
What then about all these highly processed foods that have been so refined, they now add back isolated or functional fibers and then have to add a whole bunch of sugar or salt to make it taste good, but they hype the benefits of this as a high fiber food.
Right. So fiber is a whole issue unto itself, and we could spend an hour talking about it. Let me try to make it very clear. There are two kinds of fiber. There's soluble fiber, which is like pectins, which like hold jelly together. And then there's insoluble fiber, the cellulose, the stringy part of celery, for instance. You need both. Now, why do you need both? The stringy part, the cellulose, acts as sort of a lattice work within the intestine, and then the soluble fiber plugs up the little holes in between. And when you have the two together, you form a barrier, a gel. You can actually see it on electron microscopy, which acts as a secondary barrier to prevent absorption of nutrients from the gut into the bloodstream rapidly. This means that more will go down, further down the intestine, and will be metabolized by the bacteria in the intestine, and you will never absorb it. So you may eat it, but you won't absorb it. Perfect example of this would be almonds. If you eat 160 calories in almonds, how many of those calories do you actually absorb? 130. So 30 calories are lost to the bacteria in your gut. That's kind of good if you're talking about obesity. So fiber is really very important, but it's been excluded from our diet by the food industry because it doesn't work for them.
But consumers are increasingly interested in fiber, and so I've heard you say, among other health professionals, you look for 3 grams of fiber or more per serving, but that's almost not a good rule of thumb to go by anymore, because things like frozen ice cream bars and yogurt now have 3 grams of fiber or more.
Well, they've had soluble fiber added to them. You can't add insoluble fiber because it would basically gunk up the food. So soluble fiber, like I said, is important, but it doesn't work without the lattice work of the insoluble fiber. As soon as you turn a piece of fruit into a smoothie, in a blender, for instance, you've sheared the insoluble fiber to smithereens. It's not there anymore. You've destroyed it. The soluble fiber is still there, but it doesn't do the job without both. So the idea of adding fiber to a food really does not make sense.
So we're here to speak a little bit about the relationship between sugar and metabolic disease. In addition to just adding excess calories that give unnecessary weight gain, what other metabolic effects do excessive sugars in the diet have on the average human being?
So let's call it excessive sugar, that is fructose, the sweet stuff. Because as soon as you say excessive sugars, it makes things very complicated when we're talking about other things. Okay, we're talking about only the sweet stuff, fructose. The point is that because of its unique metabolic signature, if you will, it drives mitochondrial dysfunction. And when you drive mitochondrial dysfunction, you drive all of these other chronic metabolic diseases. What else does it do? Well, the other thing it does is it acts on the brain to promote continued consumption by increasing reward. And there's an area of the brain called the nucleus accumbens, or the reward center. It's where all substances of abuse act. Nicotine, cocaine, amphetamine, morphine, heroin. And it also is where sugar acts. And the problem is that there are receptors in that nucleus accumbens called dopamine receptors, and they go down when they are flushed with dopamine. So the more chronic the exposure, the more you need to be able to get the same level of effect because the receptors have been downregulated. Sugar does this as well as any substance of abuse. So this leads to a phenomenon called tolerance, and tolerance means you need more to get the same effect. And sugar does this as well. So sugar tends to drive continued consumption through tolerance. So when you put the two together, you put the peripheral metabolic effects and the central, if you will, addictive effects together, and you have a recipe for disaster. And that's what we're seeing worldwide now.
What do you recommend that our average student who's listening today can do to help counteract some of these, the metabolic changes that they're seeing if they do consume more of these sugars?
I can sum it up in 3 words. Eat real food. Real food has fiber, and real food is primarily low in sugar. Even sugar cane, the highest concentration of sugar there is, it's a stick. You can't even eat it. You can't even chew. You can barely suck the stuff out. That's on purpose. That's what nature intended. The problem is when we purify the stuff, just as when we purify any white powder, whether it be cocaine or salt for that matter, that concentrates the dose and ultimately leads to a over the threshold effect. And once you've achieved the threshold in the liver for fructose, you start getting disease. The question is, where is that threshold? And it's probably different for different people. For some people, it's very low. In particular, Latinos seem to have a very low threshold and get non-alcoholic fatty liver disease at a very low level. Some people have a much higher threshold. Obviously, anything you can do to increase your threshold would be good. One of those things is fiber, and the other one is exercise. And that's what we say, is eat properly, eat real food, exercise, and you're good to go. And that's what I espouse as well. But I do it based on the science.
You recently wrote a book called Fat Chance, and can you tell us a little bit about some of the scientific findings that drove the creation of that book?
Well, that book started with one patient, a 6-year-old Latino boy in Salinas who was wider than he was tall, and I was getting the history from his mother as to what he drank, not what he ate. And I found out he drank a gallon of orange juice per day. When I did the math on that, that was 112 pounds of fat per year. And I tried to explain to her, eat the fruit, don't drink the juice. And she said, then why does WIC, Women, Infants, and Children, a government entitlement program sponsored by the U.S. Department of Agriculture, why does WIC give it to us? And I thought to myself, yeah, why does WIC give it to them? And that was the beginning of that book. And what the book does is it chronicles the science and also the politics that have occurred over the last 30 years, coincident with this obesity and metabolic syndrome epidemic that we are all experiencing worldwide. And it very specifically discusses what about our diet has changed. Sugar is the big one. Now, there are other things as well. It's not just sugar. The change in the fat content of our food is very important. Also, alcohol, branched chain amino acids, which you get from corn-fed beef, not grass-fed beef, and finally, trans fats. These are all very significant and specific inhibitors of normal mitochondrial function. And they all are associated with metabolic syndrome. But the one that has been going through the roof and the one that we have tacitly allowed to basically take over our lives is sugar.
So would you, in your professional opinion, do you think we have the capacity to turn the tide on this, or are we too far gone and now need to do damage control?
Well, we certainly need to do damage control, but the question is, how do we get the sugar out of the processed food? And the answer is the food industry at this point in time has no impetus to change. They are making money hand over fist. This is going to require some sort of executive or legislative influence in some fashion. The problem is they don't want to go there either because 6% of our exports are food. So this is going to require some legal challenges, and that's where some of this is headed.
So can those of us who work in healthcare, as opposed to, we can't go up against big food business, but can't we work to encourage people, as you say, to eat real food? Just to, if at all possible or when possible, to minimize the amount of processed and refined foods that you eat out of a bag.
That's right. That's exactly what we can do right now, is explain that a calorie is not a calorie. All calories are not the same. If you count calories, you're doomed to failure. And that is what we have seen for the last 30 years. That is not what the companies that espouse this would have you believe. They believe, well, if a calorie is a calorie, then you get to choose your calories. And if you are what you eat, everyone gets to choose what they eat. The fact of the matter is, if a calorie is not a calorie, then it really does matter. The food quality determines the quantity. And the problem is that our food quality right now is just god-awful.
Plus they tell you can always just exercise it away. That's the other option.
And you can't. The fact is that there is not one study anywhere in the world's literature that shows that exercise promotes weight loss. Why is that? Because it causes fat loss but muscle gain. Muscle ends up weighing more than fat. And so there are no studies showing that exercise promotes weight loss. It clearly promotes metabolic health, and I am all for it, but know what it's for. If you expect to lose weight by exercising, by seeing it on the scale, you will be sorely disappointed.
Well, thank you very much for your time today. We really appreciate you coming to speak to our students about this important topic.
It's my pleasure.